In this video, I'm going to show you how to solve the ALEKS problem called predicting the reactants or products of ester hydrolysis. There are two different versions of this problem. I'm going to show you how to solve this particular problem, and then after that, I will show you the other version of the problem. So in this problem, we're provided with the structure of an ester, and we're being asked to predict the two products of the reaction. In this version of the problem, where you're being provided with the reactants, there are going to be two products of the reaction, and you're going to want to draw the structure of both of them into the box down here. So again, there's always going to be two products in this reaction. To help us predict the structure of those two products, it is useful to redraw the ester that's provided in the problem, which is what I'm doing right now. So I'm just redrawing the ester that's been provided to us. We need to break this molecule into two pieces. That's what hydrolysis is all about, breaking the molecule in half, and it's going to break into two pieces at the ester functional group. So you're going to want to find the ester functional group in the molecule, and you're going to break it at the ester functional group. It's really, really important that you break it in the right spot, because if you break it in the wrong spot, your products are going to be wrong. The ester group gets broken at the end of the carbon-oxygen single bond. So you're not going to break it here on the side where the carbon-oxygen double bond is located. That part of the molecule stays intact. You're going to break the molecule apart at the end of the carbon-oxygen single bond of the ester group. I'm just going to do that. Just break it into two pieces. One half of the molecule becomes a carboxylic acid. The part that has the ester group still attached to it, you're just going to add a hydrogen to it, and that's one of the products of this reaction. The other half of the molecule, the other piece that we broke off, this piece becomes an alcohol. So you're going to add an OH to it. That's the other portion of, or the other product of this reaction. Notice in this reaction, we are adding water, H2O. There's the hydrogen of H2O, and there's the other hydrogen and the oxygen of H2O. So these are the two products that this problem asks for, and you would want to draw both of these in this box if this is the version of the problem that you are given. Now the other version of this problem, like I said, there's more than one version. The other version of the problem would give you these two products. I'm going to go ahead and get rid of that highlighting. It would give you these two products, and it would not give you the structure of the ester, the starting ester, and the problem would be asking you to come up with the structure of the ester from these two molecules. So basically you're just doing the opposite of what we just did. Now if you get that version of the problem, and it is a little bit trickier, what we're going to do is I'm just going to copy this down here. You're only going to be drawing, if you have this version of the problem, you're only going to be drawing one thing in this box. It's just this product right here. So you need to basically undo this reaction. Instead of starting with one molecule and breaking it into two, you're going to be starting with two molecules and combining them into one. Now what I like to do is look at these two molecules and find what will eventually become the ester functional group, which is this portion of the molecule right there. And I know that the ester portion of the molecule is going to include that little carbon chain that's attached to it, but I'm going to be getting rid of this hydrogen out here. That's eventually going to go away. And this point right here, when that hydrogen goes away, is going to become a point of attachment to this molecule over here. Now this molecule, when I attach these two together, this molecule is going to get rid of its OH. So I'm getting rid of a hydrogen from one and an OH from the other. Those are just going to go away, and these two molecules are going to combine together into one. It's a massively long bond there, but I can just kind of scooch that together. And that's the structure of the ester if you're being given this version of the problem.